Hi friends, today I'll be talking about data analysis of 1 factorial and 2 factorial experiment, both for completely randomized design and randomized complete block design. So for this I have sample data of 1 factorial experiment is here, and another is sample of 2 factorial experiment you can see here. Before that, please don't forget to like and subscribe this channel for further information. Please refer to previous videos for arranging data, calculating average, and saving the data in CSV format and making folder to set as working directory. So let's begin the process. For the process, I'll be opening the software R, and the interface of R looks like this. And then at first I'll be setting working directory by going to the session, and then I have to click on the option set working directory and then choose directory. The data is in the folder data, so I have set working directory to the folder data, and then I need commands. First I'll be running the analysis of 1 factorial experiment. So after setting working directory, all you need to do is change the name of the file. So the name of the file here is 1 fact, so I have changed the name here. Then let's run this command. Then viewing the data, it looks like this, and I need to attach the data here. Then next step is setting the factors. So for setting factors, there are 2 factors. One is replication and another is treatment. The treatment here is variety, that's why all you need to do is set the factor like replication. Please don't make mistakes while typing. The error in typing may cause problem later, that's why. So replication, and another treatment is variety. Sorry, another factor is variety. Okay, these are the steps which set independent factors as factor in this software. So after that, I need to activate the package doebioresearch. So if you need commands, you just can click on the package doebioresearch under the option packages. So after clicking, it looks like this, and you can find commands for every type of experiment here. So like for CRD, you can find command here. This is for 1 factorial experiment, and you can find command here for CRD experiment, and you just need to change the file name and your treatment here, and then the one here indicates the test for LST. It's written here 0 for no test, 1 for LST test, 2 for Duncan test, and 3 for HST test. You can choose the suitable one according to your experiment. So my experiment was of randomized complete block design. So you can find command for RCBD design here. So I'll be copying this command here, and then the name of my file is my data, that's why I'll be changing the name my data here, again here, and here. I'll be keeping 2 digits as it is because my experiment was of varietal research and there was no control treatment. That's why I'll be running the post hoc test through Duncan's multiple range test. So I'll be leaving 2 as it is, and 1:2. It represents the column on which you have to do data analysis. Like the column 1 is of replication, it's of independent factor. Column 2 is of variety, it's also of the independent factor, and column 3 is for dependent variable. From the column 3 I need to do data analysis. That's why I'll be selecting 3, 4, 5 columns for the analysis. So 3, 2, 5. You can run analysis of about 5 to 6 columns at once. So after changing the columns, I need to change the name. Here is my treatment is variety, and I have symbolized replication by writing the full name. That's why after running it looks like this. Then for the result, you can copy from here and paste to one Microsoft Word document, so that it will be easier for future for making tables. So you can save this in the working directory folder and write the name result. So for the 1 factorial experiment, you can run analysis in this simple way. Now let's run analysis for the 2 factorial experiment. So for the 2 factorial experiment, I have already set up the working directory. I will just change the name of the file. Here is my sample data is saved as 2fact. That's why I'll be changing the name. Here is 2fact. So after that, I'll be running the command view my data. This is my sample data, and then I need to attach it. To set the factor, replication, date and treatment here are independent variable, and my factor, that's why I'll be changing the name here. Right, and then another factor is date. Then likewise I also have another factor, that's why another factor is TRT. So I have already set up the factor, and I again need to look at the package doebioresearch, where I can find the commands for different kind of analysis. So as this is 2 factorial experiment, if your experiment was conducted in 2 factorial CRD design, then you can find command here. And if the if your data analysis was 3 factorial CRD, then you can find commands here. As this is 2 factorial RCBD design, I'll be finding commands from FRBD to fact. So after opening that, I'm going to copy 2 factorial experiment, RCBD experiment. You can find the command here. So let's copy this command, and after copying, you just need to change the name of your file, and name of my file is my data. My data. You need to be precise and attentive while changing the name of these variables. If you have done some mistakes on spellings or capital small letter, then you will find error while running the analysis. That's why you need to be extra careful. Date, and another factor is TRT. Experiment HST test, 2-key test is best. That's why I'll be changing this 2 to 3 for running the analysis. So let's run this command, and then 5 to 6 row of 5, result of row 5 to 6 is here. So I'll be cleaning this through Control L, and then 1 2 3 4 1 2 3 column 1 2 3 is for the independent variable, and for a dependent variable the column 4 2 4 5 6 7 8. So I'll be running analysis of column 4 to 8 at once. You can run analysis of 5 6 variable at once. 4 5 6 7 8. Okay, I'll be running to 8, and then the result is like this. You also can copy this result and save in your working directory folder for the use in future. Please don't forget to like and subscribe this channel for informative videos like this in future. Thank you.